Question 47. Jelly Bean, funny name, owns a local frozen yogurt shop. At her store, customers themselves serve a bowl of frozen yogurt and top it with chocolate chips, frozen strawberries, and any other different treats available. Customers must then weigh their creations and are charged by the weight of their bowls. Jelly Bean charges $32 for 5 pounds of dessert, but not many people buy that much frozen dessert. She needs your help to figure out how much to charge her customers. She has customers that are young children who buy only a small amount of yogurt, as well as large groups that come in and pay for everyone's together. Is it reasonable to assume that the weight of your yogurt is proportional to its cost? How can you tell? I would say that yes, it is proportional because whatever I'm going to pay for, like 1 pound of dessert, I could double that in order to get to 2 pounds. If I want to buy 3 pounds, I could times it by 3. So I'm going to say yes, it is proportional. Assuming it is proportional, make a table that lists the price of at least 10 different weights of yogurt. Be sure to include at least 3 weights that are not whole numbers. All right, so I'm not going to do 10 just to save some time, but on your paper you should have 10 of them. Make sure you have 3 of them that are not whole numbers. So you can do like 1.5 pounds, 2.5 pounds, 3.5 pounds. But I'm going to make a small little table. So I'm going to make a table going this way. And on here, I am going to do this. I'm going to have my money as my X, and I'm going to have my pounds as my over here. So let's see here what I would like to do. Let's do this. Let's do it for 0 pounds, 1 pound, 2 pounds, and 3 pounds. All right. So let's see here. And if you switch these around your table, that's fine. If you did a table going horizontal, that's fine also. So if I buy 0 pounds, of course, I'm going to buy $0. So that's always important because remember when I graph it, our graph has started at 0, 0. It's going to be proportional. 1 pound. Well, let's put this on here also. Let's put our 5 pounds on here because we know that. So 5 pounds is $32. So that's kind of my given. I'm going to work up to 1 pound so that I can get a unit rate. So I know this, that 5 pounds is, so 5 pounds is $32. So I want to work myself to 1 pound. All right, so if I'm going to do that, I could, so this is my true statement that I know from the question, 5 pounds is $32. So I'm going to divide this by 5 to get to 1 pound. Therefore, I have to divide this also by 5. Let's see. So if I do 32 and I divide that by 5, 5 goes into 36 times. That's 30. Subtract and I get 2. I'm going to keep dividing, so decimal 0, because I know that this is going to be a 20. 5 goes into 24 times, and I am done. So I know this, and since we're talking about money here, I need 2 decimal places, so that'd be 640. So I know that 1 pound is $6.40. Now from here, I can work this up to any amount I want. So I could double it to get to 2 pounds. So if I double that, that's going to be 80 cents and now $12. If I multiply this by 3, that can tell me 3 pounds. So let's see if I can do this in my head. 3 times 0, 0. 3 times 4 is 12. Carry a 1. 3 times 6 is 18, plus the 1 is 19. Now remember on your table, you were supposed to come up with at least 10 different. So your columns would be more, and you have to make sure you have some that are not whole numbers. But this at least would get me a way to start if I was going to graph it. So C, what is the unit rate for my yogurt? Well, this is my unit rate for 1 pound. So my unit rate is 1 pound is $6.40. Use this unit rate to write an equation that they can use for customers to pay. Well, let's see. I know that the amount of money is always going to do, if I take this and I multiply my $6.40, because that's the price of 1 pound, and I can multiply that by however many pounds that I want. Okay, so my amount of money is this, and actually I switched these around. So on this, this is actually my X, and this would actually be my Y. All right. So if I have 1 pound, it's $6.40. If I put in 2 pounds, and I would times it by 2, which would give me this. If I want to know about 10 pounds, I could put 10 in for X, do the multiplication, and then that would tell me how much money. So this equation here works. Now it says this: if Jelly Bean decided to charge 50 cents for each cup before the customer started filling it with her yogurt and toppings, could you use the same equation to find the new price? My answer is yes and no. So I can use this equation once again, except this tells me how much I'm going to charge for the ice cream that I put in my bowl. But remember, before you even start filling it, just to get the cup, they are going to charge you 50 cents. So I would need to add 50 cents to this equation. So we could use it, except we had to add this piece because now they're going to charge me 50 cents for the cup. So this would be my new equation to use. If I was to graph this, we would find out that it's not proportional because it would not start out at 0, 0. If I walked in the shop and I got a cup, they would charge me 50 cents even before I got any ice cream. So my graph, if I graph this, would actually start at 50 cents in 0 instead of 0, 0. So this here makes it not proportional.